So I got questioned on how do you adjust your tool when you have just a crude cutting bar like this, and some people also with the talking about the tool bit sticking a long ways out and getting vibration, and it really is amazing. You can stick a long ways out without losing much for strength. This doesn't matter nearly as much as the shaft diameter that it's supported on. Now, one of the ways you can do this is we just make it as simple as could be. We come in here with an indicator, put an indicator on the end of our tool, loosen our screws, and you just push it by hand and tighten it back down. Now it takes some skill, and that's one of those things I've said before too, is take an indicator, just practice sometimes with just moving a half a thousandths, 1/1000th, whatever, just by your hand, just the indicator itself, and practice holding it there too. It's just good practice, and if you really get good, you can put it at the end of your arms and be able to do that, which I can't do right now because I went to the gym today. It wouldn't work, but you can. You can actually get it to where you can hold it within a thousandth of an inch at the end of your arms if you practice it. Anyway, not essential, just one of those game things that sometimes play with. Now, you can watch, and of course we're working strictly with radius on this, and you can watch that this stays in the same place or a relatively flat spot, because if this turns, it's going to change your reading. You know, it's not in the machine now, but it's the same thing. If this turns, it's going to change your reading. So this is not really accurate, but it is a starting point, something that one of the ways that it's done. Now, a better way is you have a flat point, and so you change out your indicator point. And it's good to have these indicator point sets. We don't use them every day, but when you want them, and I had one with a bigger flat end on it. I didn't see it today, but I like the bigger yet flat end. And then what you do is you line it up to where, not the center of the point, but try to get your indicator going to the center of the where the cutting is. So you're pointing in from the cutting edge to the center of the shaft. So that would be the placement you're looking at for your indicator. You get square to that, and then, which we're not in a machine right now, but then what you do is you rotate this, and if you need to, you move your indicator a little bit, but you find the high point. And where that is, the high point, where it's just at the top of the cutting arc, because if you go below, you're not measuring the full size. If you go above, you're not measuring. And so that gives you a really accurate point. And when you do that, it also allows you to pull the bit out and replace it with a different one. Say this one is breaking down, but you don't want to start all over with where you're cutting. You can adjust one here, pull this out, or you can hone this a little bit to get a little better finish. And you can come back to the same point, because even if you've lowered or raised the height a little bit, if you're set to where you're rotating at that center point, you will have the same reference. Now, another thing which is really handy, and I do sometimes, is you take the back portion of this, and the shim stock is in here so that these set screws don't bite into the tool. Because if the set screws bite into the tool, you will have dimples, and it'll keep wanting to return to the same place. You won't be able to position it wherever you want it. You still get good friction on it, and banding is usually what I use for a shim stock on those. You can use brass or whatever, but you need to be careful with the brass that you don't cut through it. Now, what I will do is this, I'll take my last set screw here. We'd have to cut the shim stock off, but I'll put a little block in there. Like this is a, I thought it was 1/2 inch, but it looks bigger. I'll bet it was 1/2 inch when we first started, and I bet he went to, no, it is 1/2 inch. Okay, anyway, just eyeballed bigger. 1/2 inch bit there. So I take another piece of 1/2 inch square stock back here, and in the middle of it, I would drill and tap a threaded hole, and like a 1/4-20. So if you got a 1/4-20 goes in there, you lock it on this last set screw with a little piece there, and you can take, and every one turn is going to be 50 thousandths of movement. 2 turns would be 1/10 of an inch or 100 thousandths. So you can actually use that for quick adjustments right at the back. And they do that in line boring bars, your nicer line boring bars, which I don't have any of the really nice ones. They will broach a hole through the bar, and then in the, you've got your four corners of your bar, of the hole through your bar that your bit goes into, but on the flat sides of the bar, they'll run a tap through there also so that it has threads. So if it's a 5/8, it'll have a 5/8 18. If it's a 1/2 inch, it'll have a 1/2 inch 20. They'll use a fine thread. And again, the 1/2 20 works really good because it's 50 thousandths. And a lot of them, they'll have a very nice set screw that's made just for those boring bars. And if you're using that style boring bar, you really want to order the real set screws for it. They're hollow, but they have a machined with the axis of the thread so that as it turns, whatever point it's hitting on will keep being square. It won't be changing because of the end of the set screw walking a little bit. And then they give you usually a little tool which is calibrated with 50 thousandths. Now, there's another way this is also done, and it's similar to what you do with an engine block boring bar setup, is they will have a micrometer that sets on the bar. And it sets on the bar, guides off the bar, and the micrometer is made with a fixture so that it just hits at the highest point. It's centered with the bar all the time, and you can do the same thing you're doing with the indicator here, except you'd be doing it up this way, and you're picking up your point with your micrometer, where you can just feel it, and you can roll it along here, and when you're not to it, you won't feel it at all. You'll be able to move it, and you can just come in, and you can get very accurate movements and measurements that way. And if there's no problem with this bar being stressed, anything being, or if you don't have to do a super accurate hole, you can just go with the number on the micrometer. The micrometer a lot of times will be calibrated to go with the bar, so the numbers on it are the size that you're trying to cut. It'll actually tell you what size that theoretically you're going to cut. There is some variance in that. Part of that is bend in a bar, which if we ever get to doing some line boring project when we're filming, we'll show you some more things about line boring. But I've done a lot of it in the past. I don't hardly do it here. Main reason I don't do it here and don't do it out of the shop is it's too competitive. It's too competitive. And the nice equipment to set up to do line boring like I'd like to have, it'd be about $100,000 to buy it. I'm not going to invest that much. The cheap stuff that is adequate is around 15 to 20,000. I'm not going to spend that much either for cheap stuff. So I go cheaper yet. The stuff I've got's probably only worth 2,000 bucks, and we've built it ourselves, and it's really cruddy. It works for when we need it, you know. If we need something more, we will build something more. Okay, so yeah, line boring. And what happens with the line boring is you get a lot of competition in it. And occasionally there's a guy out here that does a really good job that's a machinist, and he charges less than what the job really should be. He can't charge full machine shop rate to do the first class job. Some areas you can. Occasionally there's somebody that really wants that, but most of the time you are competing with mechanics that are also installing the components, will do a bad job. Not that all mechanics do, but they'll usually do a not quite to size type of a job, and then since they're putting it in, nobody else knows that it's not quite correct. Yeah, the pricing, it gets pretty cutthroat sometimes, and there's a fair amount of money in it. I mean, you can do, for a lot of stuff where it doesn't matter, you can do a good enough job. And when I say the points where somebody's not doing as good of a job would be like this one over here, actually, that we just finished with that bar, where you've got a bushing that presses into a hole, and it's got to stay tight. If it's a little too loose, it will still press in, it will still look good, it will work for a little while, but your life that it's going to hold up is only about half of what it should be. And those are the kind of stuff that people just don't know because they're not here seeing that this is a good tight fit instead of just a fit. And so, and being a machinist, you want it to be the way it's supposed to be instead of just somewhere close. Now, where you've got other machine things where it's just a pin that goes through a couple of holes, It's on like the skid loaders, a lot of stuff like that that's just kind of junky anyway, even when it's new. Anybody can do that without a problem. Any mechanic can do that with very little training, and that's not a problem. But the competition comes in out here the same. In this area here, there's probably 30 different people that do line boring. As far as portable out in the field machining with milling machines, I'm the only one I know of. So I just prefer to do the stuff that other people don't do, so I don't have to worry about the competition. That's why I personally don't worry about line boring too much. But line boring is more interesting than doing mechanic work. So if I was a mechanic, I probably would get into line boring and be excited about it. But as it's more of a secondary thing for us, I'm not excited about it. Okay, back to the bars. That's a lot of rattling about stuff that didn't really matter. So you've got a bar, and you have your threaded hole in there, or you have your mic for adjusting. One of the things you'll have, and I was talking about preload, and I'll just lay this out in general. Let's say that we have a bar going through and we've got 3 points. And there's a bearing here, bearing on the other side, maybe a middle bearing, maybe 2 middle bearings. So we've got a set of arms on a loader. And the thing is, people will many times get those bearings where they're slightly out of alignment with each other. And that slight amount out of alignment is still straight enough as far as the 2 holes to each other, but the fact that they're slightly out of a line won't let you measure the hole very easily because your bore's off to one side. And sometimes it can make a little bit different bore than what you think it will as far as size too. One of the things which helps with that is, and we cheat with it here in the shop too, hones. A hone will let you take another 1 or 2 thousandths off on the top without too much trouble. Get a little bit straighter hole. Real hones, so the Sun and style hones. But anyway, the thing, besides getting it all straight, your measurement for your bore, the thing that's hard to do, the thing that's really hard to do and makes line boring a pain in your Achilles tendon is how to measure it. Because when you're going to measure this, there's a bar stuck in the middle of it. If you pull your bar out, now your tool's totally out of place from where it was, and you get extra chips under it. It's just, you don't really want to pull your bar out to get a good measurement of the hole. So one of the things you'll do is you'll come in here and you've got a bar. You'll use your telescoping gauge to measure from one side of the hole to the bar. You'll use your telescoping gauge to measure from the other side of the hole to the bar. And you know the bar diameter, or if you didn't previously, you back up your bar a little bit and measure it where you can get it out here and get a mic on it, and you add those 3 together. Now, if you're just doing a rough starting measurement, you can just do one side and double it. But again, that bar tension, when it's setting here by itself, this might be slightly off center. It may cut and push, but it may be off center when it's setting stationary. So you really, for an accurate measurement, need to get all 3. You can also get tools or make tools that are essentially indicators with little arms. They're like the old style calipers that you use by hand, and they got little points. But you need a bunch of different ones to go around different size shafts to be able to get in here. So there's some problem and things that adds to the art to make it work. One other little thing for line boring that I will, while I'm here talking about, when you've got 3 holes in line, 4 in line, whatever, 2 things with the bar. One is, if you start out with 2 of them in line, and the bar may be bent a little bit. Even good quality new bars, they're bent sometimes. So if you got one out here, you got one over here, and you want to get a middle one in the correct position, one way is to put 2 indicators on it, see the run out, and pick the middle of that position. Push the bar so that it's at that point in the middle of the run out in 2 directions. That should get it where it's in line. We're figuring that the bend is consistent as it rotates. If it's a really heavy bar, now gravity's going to play into that, and that's not going to work. Another thing that you can do, and I've seen this many times, is where you go up to a boring bar and the bearing won't spin on the shaft. Now, most of the time, if you've done a lot of line boring and you've got oil and everything working well, you'll realize that your bearing, you've got a ball bearing that's self-aligning that you use for your boring. We could actually go out to the Connex and get some of what we've got there. It doesn't matter. They know what they either know what a self-aligning bearing is, or they're out at their ain't gonna know anything. So you have a self-aligning bearing, and it's if it's lined up correctly with the bar, it will actually spin on the bar by hand. You can rotate it. If you can't rotate it, that means you're a long ways off center, or your bearing is cocked. Because even though it's self-aligning, it doesn't automatically align straight. And this is one of those little things that you see guys that don't do a lot of line boring, and even some of them that have done it for decades have never caught on to. Besides the positioning of it, and as I was saying, that rotating, part of what I was going to mention was you really end up a lot of times while you're boring, it will sometimes, as the cutting load comes against it, it will lock up and run with the bearing. And then other times it'll just sit there and free spin in the hole with the oil in between the center of the bearing and the shaft running inside the bearing, which they're good reasonable round collars, and that works too. You got to remember there's limitations to what you can do with this stuff, and that's part of where there's the art and there's hones. Also, if you don't have money for hones, you can do the not quality hone thing. You can do the flapper wheels, but you got to be a little bit more careful because it doesn't take care out around. You may have to work on flapper wheel on one side or the other to take care of something that got a little bit oval from the way the stresses was. Now, here's the trick that I was almost to say, and I save it for the last of this little discussion. When you've got your self-aligning bearing here, and you've got it where you think it's right, but it's still binding up, take a brass hammer and just tap around the face of it while it's on the bar. It will vibrate, and it will actually let it center up into the correct position. It really works great. It's just really simple. Just go bap, 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 bap with a brass hammer, and then you'll be able to take that bearing that was bound up and spin it by hand. And that is a very, very big plus if you're doing line boring. And I just gave away a whole bunch of money there to somebody, but that's okay. We're not going to do everything forever. I am mature. I am over 35 years old. And I still got hair. Yeah.